Hello, in this video we're going to take a look at finding the area under a curve on a given interval. So our first example, we have f of x equals 3x cubed, and we are looking at the interval from -1 to 5. The first thing we need to do is sketch the graph of this function to know where it's above and where it's below the x-axis. So let's use our calculator to help us out with that. So we're going to plug in our y equals menu, we're going to plug in our function, 3x cubed, and then we can go to the graph. On the window that I have set on this is I have my interval from -1 to 5, and then if you plug in -1 here, you're going to get a -3 y value, and if you plug in a 5, you're going to get 5 cubed is 125, times 3 is 375, and so that's why I've set this to go from -10 to 400, just so I can see a good picture there. All right, so if we go to our graph, we do see that this graph is really zoomed out, and we don't see a whole lot happening until we get past about 1.5. And so if we go to our table, we can actually see what those values are. So at -3, we get -81, where at -1 is where we're starting. At -3, and then at 0, it's 0, and then it goes up. If you remember from any kind of college algebra class, transformations on the cubic function has a real basic shape. At -1 here, we're going to have, let me do that a little more to scale. Not really worried about here how high it goes up or down, just whether it's above the x-axis or below. And so we do see that it is going to be below the x-axis at -1. When it gets to 0, it's going to be equal to 0, so it'll be on the x-axis, and then it's going to continue up. And we do see that our cubic shape will look something like that. Now, what we're looking for is the area between our function and the curve on that interval. And so we're looking for this area, I'm shading in red here, between our curve and the x-axis. Now, the reason we have to graph it is because we have to know when it's above and when it's below. When it's above the x-axis is from 0 to 5, and it's below the x-axis from -1 to 0. So we're going to split up our integral, and we're going to find our area is going to be the integral from -1 to 0 of our function. Our function's below the x-axis, so we're going to multiply a negative by that function because we want to get that total area. And then from 0 to 5, our function is above the x-axis, so we want that's going to be a positive area. All right, so if we take the antiderivative of 3x cubed, that's going to be 3 times x to the 4th over 4, evaluated from -1 to 0, plus 3x cubed, again, is going to give us 3 times x to the 4th over 4. This time it's evaluated from 0 to 5. Remember, we've got that negative on multiplied by the part that is below the x-axis. So we'll get -3/4 times, if we plug in a 0 there, we're going to get 0 to the 4th, which is 0, minus a -1 raised to the 4th is a +1. And then for our second piece, we're going to have 3/4 times 5 to the 4th is 625, minus 0 to the 4th is 0. So our first piece is going to give us a 3/4. Our second piece is going to be 625 times 3/4. And that is going to be 469 0.5 is going to be that area that we have in red, that total area there. All right, let's do another one. All right, so if we go to our y equals, enter our function into our y equals, here I have the window set on our interval from 1 to 3, and then our y min and y max, if you plug in 1 and you plug in 3 into our function, those y values are always between -5 and 5. And so if you go to the graph, this is x equal 1 to x equal 3. It looks like it's crossing exactly at x equal 2, but just to make sure, you can go to your table, and we do see that at x equal 2, it is exactly 0. So we're going to do our integral from 1 to 2, and then from 2 to 3. Because when we sketch our graph, between 1 and 3 is an increasing function. It's negative between 1 and 2, and it's positive between 1 and 3, or between 2 and 3. So our area here is going to be the integral from 1 to 2 of our function. That part is below the x-axis, so we need to distribute a negative. You can either factor it out or you can distribute it actually in your function. Just make sure you multiply it by everything, plus the integral from 2 to 3 of our function e to the x minus 1 minus e. And the integral of e to the x minus 1, that one technically is a substitution there. We would let u be x minus 1, and so du would be dx, and if x is equal to 1, our u 1 minus 1 equals 0. If x is equal to 2, we would have 2 minus 1, which is 1. So this integral is going to become the integral from 0 to 1 of negative e to the u plus e du. And then our second integral, the only thing that changes is we also need to know what happens when x is equal to 3. That's going to be u equals 2. So we're going to have our second integral is going to be the integral from 1 to 2 of e to the u minus e du. So when we integrate that, we'll get negative e to the u. E is a constant, and so the integral of e du would be just like if we had a 7 there. And so that's going to be e times u, evaluated from 0 to 1. And then our second one, we're going to get e to the u minus e times u, evaluated from 1 to 2. If you plug in a 1 there, we're going to get a negative e to the first plus e times 1 minus, if we plug in 0, we get negative e to the 0. Well, e to the 0 is just 1, plus e times 0 is 0. All of that comes from our first integral, and we're going to add that to, if we plug in our 2 there, we're going to get e squared minus 2e. And then if we plug in 1, we get e to the first minus e times 1. And we do see negative e plus e, that's going to give us 0. This is going to be minus a negative 1, so the only thing that comes out of that first set of square brackets is going to be a 1. Can't really simplify e squared minus 2e. And then e minus e is going to give us a 0 on that second piece, and so our answer is 1 minus e squared minus 2e. Oh, hold on, I just caught a mistake. We've got a plus sign here, so this should be plus e squared minus 2e. All right, I'll see you guys next time.